Hello everyone. Let's start the second part of topic 2. In this part, we will learn how to handle characters and character strings, which we simply call strings. Then, we create a program that computes the ciphertext based on Caesar's cipher. In the practice exercises, we study how to use characters and strings. Let's start with strings. A string is a string of characters. For example, here we have coffee. By this assignment statement, a string variable str is created and coffee, this string, is put into this str. In Ruby, actually, string is represented by sorting the characters one by one in an array. So str is actually an array. Characters COFFEE are stored one character at a time in an array named str. For example, then this array is handled as a string. We can access each character of a string like an array. For example, by str bracket 2, we access the second box in this example. The box that contains the third character of the string coffee. Remember, the boxes of an array is indexed from 0. Let's see some example and discuss how to handle characters and strings. Suppose we have created a program called string print.rb, as I will show you later. Let's try running the program. You can then ask by putting the string into the computer. Then assume that you type in a string, this string, TIC%TAC, and press Enter key. This pressing the Enter key conveys to the computer that the whole string was put in. So the computer processes it and displays the characters one by one on the screen. This program, string print.rb, works in this way. By the way, recall that in this lecture, I'm using these yellow characters for those to be typed by the human, while white characters are outputs from the computer. Now, let's go ahead and take a look at the program. This is it. Let's examine the program from the first line. The first statement is the puts command. By this command, the message input a string is displayed on the screen. That is, the computer asks the human to enter a string. The next one, this one, is the command to input a string and store it into the array str. More precisely, this gets parentheses dot chomp, I call it chomp, is a command that forces the computer waits for an input string. This gets .chomp is also an expression whose value is a string given from the human through the keyboard. Then, by this assignment statement, this value is stored in a variable or array str. In summary, by this statement, the computer obtains a string that the human types and store it into the array str. Well, let me skip any further explanation in this lecture on this statement. So please consider, for example, this expression gets.chomp as a set expression or formula in this lecture. Let's move on to the third line. By this statement, the length of string in the array is obtained and it is stored in the variable n. Remember, we studied this command before. Yes, we used it to measure the number of boxes used in an array. Here, the number of boxes in str is nothing but the length of a string kept in the array or the string variable str. In this example execution, 7 is put into n because TIC%TAC consists of 7 characters. Then the computer executes this part, that is for loop. As the variable I changes from 0 to n-1, that is 6 in this example, the value of the ith box, stri, is displayed on the screen. Next, let me explain a character code. As we studied in topic 1, everything is expressed as a number in the computer. Characters too. Each character is related to some specific number, and characters are expressed by such numbers in the computer. The correspondence between each character and the number is called a character code. There are various types of character codes, but the most globally prevalent one that represents alphanumeric characters is called ASCII. On the other hand, for Japanese, well-known character code for Japanese characters is not unique. For example, SGIS, EUC, and Unicode are popular codes for Japanese characters. Note that each code defines its own correspondence. Thus, using Japanese characters, kanji or kana, would be a little too complicated. So we will just consider English letters and only ASCII as our code. There are two important commands for using ASCII. The first one is to compute ASCII-based numbers for characters in a given string. For example, consider these two statements. By the first statement, a string C, A, B, C is stored in an array or a string variable SS. By the way, this is the way to initialize a string variable. Then, by the second line, a sequence of numbers corresponding to the characters of a string in SS is computed and then stored into the variable AA. Here, string variable name in this example SS, this one, SS, dot unpack C is a command to compute an array of numbers corresponding to the string. In ASCII, an uppercase letter C corresponds to the number 67. Okay? A lowercase letter A corresponds to 97, B 98, C 99, and Z 122. So the sequence of 67, 97, 98, 99, 122 is created and stored into array AA. Again, please consider it as a set expression. Anyhow, this expression can be regarded as a sequence of numbers to corresponding characters in the array SS, this one. Okay. Then this value is stored in the array AA in this statement. Similarly, we have a method for converting a sequence of numbers to the corresponding sequence of characters, that is a string. Consider now these two statements. The first line, this one, is to define an array AA as an array of integers, these integers. By executing this line, this statement, one array called AA is created. Then, by the next line, the sequence of numbers in the array AA is transformed to a sequence of characters, corresponding characters, and then it is stored into the array str. In this example, CABCZ is obtained and stored into the array SS. Here, the name of array, this one, followed by pack C star, is a command to transform each number in the array to the corresponding character. Again, please consider it as a set expression.